recording.
Oh my gosh.
View, slideshow, present. Okay. Make sure nobody's trying to join there. I'll hear it if somebody tries to join. Okay. We're recording and going forward right now. So, welcome to the second presentation from the Builder Crash Course. We're covering a lot of different theoretical aspects of the building world of building and construction. A big part of that is actually rapid learning, because what we're trying to do here is impossible, and rapid learning is required to learn integrated skill sets. Rapid learning is a critical aspect of what we're trying to do. Like, we're trying to solve big, hairy, audacious goals or intractable problems. So any effort of transformation must start with a program for how we learn more, learn better, and accelerate our learning for integrated know-how and practice. So let's begin with creativity, problem solving. And you guys take notes and ask questions at the end. Let's save the questions for the end. But the thing is, to solve problems, you need to be creative, naturally. And that's called divergent thinking. Divergent thinking is the opposite of logical or convergent thinking, where you're thinking about, I don't know how to define it, but divergent thinking is that kind of thinking where you're thinking of infinite possibility as opposed to narrowing problems down to smaller problems. So the thing about, I'll actually go to the, let's see, can I go to the wiki? Yeah. I'll be switching like between the presentation and this. But 98% of, so a study has been done. You can click on this link here on YouTube. Wait. Am I sharing my screen? No, I'm not sharing my screen. So let me share my screen. Entire screen. Share.
What I want to do in the little time we have tonight is to share with you something, an idea, some knowledge that.
So Eduardo, you might want to mute that. Or, no, that's me. Oh.
And
so that's me. There's a talk on this I'm referring to here. But studies have been made where they took a whole cohort of 4 to 5 years old children and trace their life and calculate, basically tracked how their creativity happens with time. So according to their measures, at the young age of 4 to 5, 98% of children are creative geniuses. They can think of crazy things, and they're not abridged by any kinds of preconceptions of reality. So that's divergent thinking. But by the time we get to 31, according to this NASA study, and there's a talk, TEDx talk on this thing, only 2% remain as divergent thinkers or creative geniuses, what is called. By adult time, 50 children are creative geniuses. I actually think that's a way of an overstatement. How many geniuses do you see around you, like per 1,000 people? I mean, genius is pretty rare. Genius is a high level of performance that, somebody who's just crazy performant in some kind of aspect. But we lose this over time. Okay, so the question is, let's regain it. And let's think about various tools, and then how do we regain this creativity? And it's important for us for many reasons. Like, for example, we're trying to learn 20 trades in the time it takes to do one. Like, you gotta be able to really think and solve problems and come up with better ways of analyzing problems. And it's a thing that we never learn in school. Like in school, I mean, I can tell you personally, I've never learned anything about things like rapid learning or mental models or logic. I mean, I never took any courses in that. Or things like speed reading or memory improvement or mind maps, which are some common tools that are used to improve yourself. So things like the Global Village Construction Set, it's a big, hairy, audacious goal. It requires some creative thinking. Things like that's why we're starting the Future Builders Academy, to learn how to solve problems, learn how to think effectively. And And things like the seed eco-home, the integrated systems, which combine construction, energy, materials, landscape design, agriculture, manufacturing. At the end of the day, like I talked about, the solving housing, big, hairy problem, and that integrates all these things I just mentioned. Industrial economies in a box, which the Global Village Construction Set embodies. It's a huge amount of information and content in there. So you got to be able how to process information. Like, so you talk about solar steel, mixing enterprise, physics, production, to generate high revenue per day using a solar 100 kilowatt induction furnace. I mean, that's a big deal. I mean, nobody in the world is doing this right now. So we're saying, hey, we need to think very clearly, especially if we're going to be building experimental prototype communities of tomorrow. This is the Epcot Center, which actually Epcot stands for that. But of course, that failed miserably in its mission. It went from so Epcot actually, if you look at this, I like to point this out. Epcot Center, the thing by Disney that you all heard of, right?
Yeah.
You probably been there. Who's been there? I've been there. I remember some aquaponics and stuff they had in there. But it's this amusement park. But it wasn't. Yeah, it was. If it was really an Epcot, an experimental prototype community of tomorrow, showing a model civilization, that would be cool. But it's not. So that's not what it is. So we have to think about the art of possibility. Like, one of the tools we have to think about is how do we regain that childhood ingenuity. And one book I actually talk a lot about in terms of the practical tools, the art of possibility. How do we regain it? There's this is actually a thing I really liked. I was brought onto this by my mentor. But how do what are the mental patterns that you have to establish to think in terms of possibility, as opposed to there's a problem, I cannot solve it, I am stuck, I'm gonna die or whatever. Art of possibility is that you have no problems. Everything is a solution and a possibility. So
who wrote it?
This guy Zander, last name is Zander, Benjamin Zander, with his wife. He's actually a performance coach. He's actually a surgeon as well. But it's actually worth looking at some of the principles. I'll go through a few of them. But the first thing, like, realize that everything's invented. Okay, so that's a mental model. What is that? Everything about us is, one, created by humans or filtered through mental stories. We can create whatever reality we want to. If we recognize that, we can do it. There's other things like, move from scarcity to abundance thinking. Like, stop thinking that, there's not enough, but think about abundance. That's a great tool. There's focus on we, meaning collaborative. I like to do that. Leading from any position so that anyone on a team can take leadership. So go through this, actually. I would recommend that. If I'm going to go through much more than this. Art of possibility is what we like to learn about. So we have to get aware of the possibilities out there before we pursue them. If we don't know something is even possible, we're not even going to pursue it. So the whole idea of our program is, let's push the limits of what people are aware of in terms of possibility and study that. So that's part of the stuff we'll be going through. And part of that is multiple intelligences. You might have heard of like regular intelligence, emotional intelligence, but there's like hundreds of them. There's a whole list, and I'm going to click on that. Just look at all of this type of stuff that are actually a thing. Like, we already talked about divergent thinking. It's an intelligence that's embodied in the art of possibility. So if you want to study that, read through the art of possibility. I mean, there's technical, practical problem-solving intelligence is like.
Kinesthetic intelligence.
There is. Things like tool invention intelligence, like even product scaling. I mean, this is Chat GPT, and I basically asked, hey, Chat GPT, what are all the different kinds of intelligences? Give me a list of like 100, but there's tons of them, and just to even.
Did it list itself?
No, it didn't. Suzanne, we'll save the questions for the very end because you got to take out your notebook and do. But there's just reading through this list and knowing, hey, that's a thing. Like, like perspective intelligence, like when we're reading our blueprints right now in the workshop, well, if you have zero perspective intelligence, you won't really be able to tell that, oh, this is from the top view, side view, other view, things like that. Like there's all these different intelligences that as soon as we start becoming aware of that, we can start actually improving that, because if we want to be high performers who can now solve any kind of problem, there's, yeah, like Susan mentioned, kinesthetic intelligence, modal learning, agility. Let's say, oh, how do we learn to use the cordless saw in an effective way or whatever. All these things relate. Empathic attunement, how's that related to housing? Well, the fact that we're trying to solve a major pain point for a lot of people, so we have to have empathy for a lot of different people. I mean, negotiation intelligence. I like that, because I mean everything is a negotiation in life, whether you know it or not, and the worst kind of negotiation is one that you don't know you're in. But there's a book called Never Split the Difference. I love that book about that. So for every topic here, we can actually start, and actually invite this as a collaborative exercise. This is a wiki page, but I mean, start putting down, developing this page to, for example, like, okay, examples of this, or good resources on it. So there's thing like fabrication intelligence is, did you ever hear that? Is that a thing? Well, let's click on it. What does ChatGPT say? Oh, this ChatGPT is broken on it. Yeah, it doesn't like that on this old computer. But yes, sure, it's the awareness that there is modern digital fabrication and things like Fab Labs and maker spaces, and the idea that you can build anything. But if you don't have the intelligence to understand that, you'd be like, how do I do that? How do I even begin to think of creating my reality? So many of them, and it's just amazing. When I first saw this, I was like, holy cow, this is just blows my mind, because it's powerful. And then when we talk about intelligences, we typically talk about just plain logical intelligence, emotion. You've heard of emotional intelligence. And I always like to say that moral intelligence is the start of all that. In terms of moral intelligence, is that purpose of right and wrong and good versus evil, the kind of stuff that can really give emotions to fire you up to do certain things and avoid others. I think that's a key driver for high performance, in the sense that if you're fundamentally driven by the forces of good, you're going to have infinite energy. You're going to be reinforced by people who like your work, as opposed to, like, say you're doing, like Darth Vader, something evil. You won't name any names, and then you'll have a lot of resistance, or maybe not, but there's a fundamental support that can come from just being oriented in a good direction. So actually, I invite you to a self-test. What is this self-test? So I actually did a spreadsheet. Hey, take a list of these 100, whether you heard of them or not. They're described here, all these intelligence. Rate yourself from 1 to 10. Like, do you think you're off the charts on this kind of skill? Do you completely suck at it? Like 0? Like you never heard of it and never even, like, what is that? It doesn't make any sense to me. But in principle, all these things have significant meaning, so it's worthwhile to do that. And I haven't done that myself. I will. But it's 100 things. But just go through this real quick and see. It's right in the presentation. So if you do self-test yourself, it leads to this thing. And I would like to do, for the people that are in the program, do it, and then become aware of that right now. In 4 years, or every year, just do this once. It'll take you 10 minutes, 15 minutes, and see if you went off the charts, or improved, or just stayed the same, or got worse, and all these. And so we can track it over time, because part of this experience here is, are we actually learning all these things because we become aware of them and we start expanding our awareness, or index of possibilities. I like that word, the index of possibilities. Like, what is even feasible? Oh, I didn't even know humans could do that, right? So once you become aware, you can hopefully it's a motivator, not something that, oh, well, I can't do that. Well, no, if you have a growth mindset, you accept everything as an opportunity. It's not a threat that, oh, I don't know these things. No, look at it as an opportunity to grow, because that's what we're about here in this program. So just do a file, make a copy of this document, make a copy, just make a copy for yourself. So Marcin's test, Marcin's evaluation of intelligent, this is multiple intelligences, yeah. So do that and see if that actually you get any benefit out of it. I would encourage, definitely. So then on one side there's intelligences, but on the other side it's actual literacies. So intelligences are more things that you might have some capacity in, like you have an amazing mathematical intelligence. But just because you have that intelligence doesn't mean that you're great at it, because it means that if you practice it, you'll get super good. There's the element of you have that intelligence, but if you don't work it, you're never gonna get good at it. So that's why the first thing is become aware of those intelligences so that you can improve them by working on them. And there's no magical, I don't believe this born genius stuff. You have tendencies to have these intelligences, and maybe like you're off the charts on musical genius, Mozart or whatever, this or that. But if he didn't practice, he wouldn't be Mozart, right? So I don't believe in this thing like this born genius thing, and people, Michael Jordan, this or that. Like people like to show in the media that you're this superstar out of nowhere. No, it is all hard work. It is all you're putting in the hours. You're putting in those 10,000 hours to develop that intelligence, and then you become rock solid at it. And the idea here is that, well, we're trying to find methods where, because there's just so much to learn, how can you actually increase your capacity to do it? Now, literacies are actually things that you have learned. So now if I'm collaboratively literate, which I claim to be, for example, I actually have some skill in the practical and organizational things of how to work with people and coordinate large groups to do things. It's a skill that has been developed. So the literacy is kind of like, I would look at it as literacy as a developed intelligence. And just kind of making these distinctions is helpful. And once again, take yourself a little exam. And if you and so once again, rate yourself 1 through 10, make a copy of this. But if you do both the literacies and the intelligences, I think they're correlated by all means. If you have an intelligence in something, you can definitely improve your literacy in that product. Like so what are some of the literacies that we're talking about? I'm just clicking on that here, but tons of them. And this is once again ChatGPT, so it's kind of some BS in here too. But like reading literacy, it's like understanding written text. Well, yeah, right. But then there's how do you put that on steroids, and how do you super improve that? That was my value added, like speed. I'll talk about speed reading, but this is kind of like basics. It didn't even have, if I do control find, it didn't have collaborative. Oh, it has the closest to, let's see, it has a remote collaboration literacy, and that's under actually like digital and technological literacies. It has what other literacy? It did pick out collaborative literacy, working productively with others. And that would include both the social aspects and the technical aspects. So if you don't have the tools like wikis and FreeCAD to share design globally, you can call yourself working productively with others, but you can't collaborate with the whole world. So there's all levels of expertise you can do in all these, and this is all kinds of things. Personal mastery, like learning to learn. Do you actually good at improving your learning skills? So anyway, lots of things just to get aware of this, like health literacy. How aware are you that whether you're healthy or not, whether you actually have enough energy in your life, all these kinds of things. There's scientific, there's definitely cognitive and thinking, like are you a designer? Do you have good metacognition, the idea that you can actually think about how you think? So all kinds of things. For us, we definitely studied I mean, we definitely study the digital and technological literacies, but all the other ones are there for your generalizing our skill sets, like financial and economic literacies, like entrepreneurial skill. Of course, that's the big one. How you ever gonna implement anything in the world? So there's that. Take the exam. I'd love to see it. We can compare notes, and don't be shy about it. If you score low, it's only an opportunity to grow more. And then you can go up, you can degenerate too. I mean, you can go both ways. If you don't practice something, you can completely lose it. There's neuroplasticity. We learn and then forget and things like that. So we take on a multifaceted approach to learning. I call it integrated learning. So what we do here is learn across disciplines, viewpoints, mental models, time frames. Like, what's this all mean? Time frames. Like, for example, long-term thinking. We think about, what do we got to do to build a house right now, but also how we are going to solve housing in 10 years when this thing takes off. Goal is to get a holistic perspective. It's both hands-on and applied problem solving, and includes, I would say, includes teaching. So teaching, if you look at learning, people say that teaching is the fastest way you can learn something. It's more than hands-on learning. If you're going to teach someone, you are forcing yourself to understand something at a different level. The collaborative creation of genius, I mean, I think society is way removed from this collaborative creation of genius. In fact, I mean, schooling and media and all these negative messages and inferiority messages and things that come out, instead of this collaborative culture where we're trying to uplift everybody. And we do want to create, I mean, I call it an open source genius network, where, what is that about? I mean, open source genius network would be something where, like, all the companies decided to share their top technology, and like that's one example of it. I mean, imagine everybody, like in Africa, could now start producing microchips. You know, like, why not? They just don't have the know-how, or it's all proprietary for one. So that opens up the possibility of authentic learning, and I define that as the ability to learn. Like, I look at it as learning free from the barriers to open learning, meaning free from all kinds of special interests and proprietary information that influences what you learn. Like, for example, if I go to a website and I read about some product like a car, obviously you're biased by some company who's trying to get your cash or whatever. Like, typically, I mean, there's some products out there that actually really try to educate you. Not a lot. I mean, typically that falls into the category of open source products, which part of their core mission is to educate people about how something works, as opposed to make money in a different incentive. But authentic learning is that when, for example, I give this example where even in grad school, I could not talk openly about my research to other groups, which I'm like, this is really bad. That's clearly preventing me from discussing and learning more about what I am doing. Isn't that ridiculous? And that's another example of authentic learning. It's not happening even at universities. The silos are a big issue where, as I mentioned yesterday, that if you do not know how everything connects, because we are in silos and people are hiding stuff and there's trade secrets, authentic learning cannot happen unless it's open. And therefore, by default, we create a society that's second best. I mean, stuff that's a lot of inferiority is being promulgated because, the best company has it, and then it tries to prevent others from doing the same. And you really, what's second best? I mean, second best, I mean, I look at it as the idea. I mean, somebody wants to join. Yeah. Second best, I mean, I call it the concept that's how I felt about my education. It's second best. I'm not learning anything that actually works or is practical. Like, for example, when you try to do an induction furnace right now in school, you're going to learn, we want to make metal to make $5,000 a day making complex metal parts with CNC mills. Well, for the induction furnace, I can learn some theory, and here's some circuit diagrams, Great, but how do you turn it into a product? There's a whole big layer of information that's missing, and you don't learn that. I thought, I actually started in chemistry, and I thought I'd learn all this applied stuff, and instead, like, I was drawing up like these theoretical molecular orbital diagrams all day, like instead of actually saying, oh, here's how I make fuel for a car, or like, develop some new chemical, new useful chemistry or something, or this. So it's like ridiculous how far out you get in terms of practical info. So with that said, multifaceted approach must be open. Now, general semantics, I like to talk about general semantics. That's the actual study of meaning. If you haven't heard of that, and it's like nobody has heard of what general semantics is, but that's it's how words relate to reality, like how you construct your mental models of what's real and not. It's a subsection of semiotics, which is this general study of symbols and meaning. But general semantics, you heard the map is not the territory, right? That this man, Alfred Jakubowski, he's actually a Polish dude from the turn of the century. He coined that the idea that map is not the territory. That it's a critical element that most people think that what they see is the actual reality, but it's actually far from it. You're interpreting that through your senses, through your prior experiences, and everything else. A lot of stuff is just not the way it seems, and a lot of people are like, no, this is it, and it's a thing that prevents you from having that. It's this reductionist kind of thinking that prevents you from being a divergent thinker. You just think, oh yeah, that's the reality, bam, it's right there. But no, that's not how things work. And down to quantum mechanics, there's uncertainty, right? Like there is no. The perception is quite skewed, and when you're aware that it can be quite skewed, you're just a better mental modeler because you don't start believing your own religion too much and get stuck in mental models that are just not accurate. So it's all about forming accurate mental models of reality. If they're not accurate, you're going to be led down a lot of trouble. So general semantics, Jakubowski, he coined the term, the map is not the territory, and time binding. And what's time binding? Let's look at these. Actually, let's click on this. I wanted to just. I got out of there. Sorry. The map is not the territory, about perception. I'll leave it at that. Now, time binding is. So Jakubowski also talked about the concept of time binding, which is the unique human ability to build upon former generations' work through writing, I guess with the invention of writing, now we have computers to spread stuff, but no other animal can really do that. They don't record things. They can teach others, but not teach other animals, like, teach their offspring, but they don't really have the ability to transfer complex technology downstream to people. Now, that's a really important concept for us here, because what we're doing is we're saying there's all this technology of humankind. How do we actually build upon it? And the first recognition is that, well, because a lot of this stuff is proprietary, like all the stuff that's called the life stuff, the best stuff in civilization, it breaks the concept of time binding. Everyone's trying to hide it. And then in 19 years, the patent runs out, and you got this delay. But we talk about the concept of economic time binding, and that's this idea that in the realm of economics, how do we allow like all that enterprise information to be transferred for near like zero cost or near zero startup cost of the next one? That's when you apply the concept of time binding to the economy, which is what we're doing. We're trying to say, hey, we're going to shift the economy to open source, and economic time binding I think is a very important concept for us to recognize, in the sense that we're lowering the barriers to entry, ultimately to enterprise, to zero. So, one is the information content, right? That's time binding. We transfer complex information, but for hardware, unlike software, it's so much more complex because it requires atoms and costs. Like each prototype of the house that we built was $60K and stuff like that. materials, tools, infrastructure. So how do you crack that question when you're talking about hardware? And that's and our answer to that, what we propose, I mean, we're working on that exact question, and we say that, I mean, open sector enterprise, I mean, is exactly what we're doing. We're saying we're creating public infrastructure that allows others to start up easily. Like, in practical terms, what's that mean? If somebody wants to build a low-cost house, we're building the hangar where 5 people can build a house at the same time. We provide all the infrastructure. So we're like eliminating all those capital and infrastructure and startup enterprise things and making it accessible to the public. So for example, why don't we, for example, rent the hangar? You know, we can rent it for some entrepreneur to, like, say they come to the stage with no resources, then we can educate, we can provide resources, like, say, you know, like public infrastructure facility. And that's exactly what this open sector means. It's the thing I mentioned yesterday about universal basic assets. It's access to infrastructures that allow you to do just about anything. And that's really, like, how is this related to learning? Well, we're learning how to spread enterprise in an effective way. It's just an element. And if your learning is connected to your livelihood, then you have just such a much more powerful method of learning, like a motivation. You've got fire under your pants. Like when my tractor broke, I was like, either I go poor and get angry, or I build my own and then create that wealth. And but I had a real fire to do it, and then, like, no problem is a problem. You just come up with solutions because you need to. So necessity is the mother of all invention kind of deal. But if the economic question of your very survival depends on your learning, then you're going to be very motivated. Now, school doesn't necessarily work like that. It's kind of unclear how that your schooling is going to connect to your job or whatever, or some meaningful pursuit. So you're not, from the get-go, able to learn properly, I would say. Write down the question.
I will write it. I've written it in my mind.
And you're going to forget, according to what I'm going to say next. So, no, it's slideshow. Let's go back to the slideshow. So, economic time binding. Now, okay, cool. Neurogenesis. Can you believe that? So, for all this time right now, people thought that brain cells aren't born. They discovered they do in 1998. Look at the wiki page. So, can you believe this? Like, for like 2,000 years, we thought, or like modern science thought that, you're kind of stuck with your brain, and beyond the childhood you don't make any brain cells. It's actually not true. So this is extremely important for positive psychology and the ability of people to learn. If you can actually make brain cells as an adult, then that's some fuel for actually developing further your growth mindset. It's directly related to your ability to even make the growth mindset feasible for yourself as a concept. So, but this is real, and you can read the science behind it. So let's talk about some of the tools that I find super effective for learning. Mindmaps, I would say, that's a visual learning. So Tony Buzan actually ran into this work probably 20, 30 years ago or whatever. But Mindmaps, that I think, are an extremely important and easy way to learn things. So what are some examples? So it's visual ways of organizing information. Look at these things. So how do you take a complex problem and map out all the relationships in it and do it in a visual way? Because this is about the multifaceted approach to learning. There's visual learning, there's kinesthetic learning, there's mental learning, there's auditory, and there's performative learning where you learn by doing, things like that. So this just adds another dimension. You're starting to use more of your mind, the mind that we use. I don't know what the facts are on how much of our mind we use, but we can certainly use much more of it. So mind maps are a very powerful tool. And the wiki actually mimics a mind map, because a mind map is a thing that has connections from one thing to the other. So on the wiki, for example, where you have hyperlinks, you can go from one concept to the other, and you can organize the wiki. Even you can, in the wiki, you can do like graphical indices, where I do this a lot in my work docs, where if you have some complex topic, you break it down into like all these mind map little bubbles and elements of something, and then if you put hyperlinks to it, you can jump to that information super quick, and you can organize that. So while the wiki is a dump of information, you can actually put layers of organization on top of it. Okay, speed reading. So who thinks that speed reading is about reading fast? You do? It's actually it's speed reading is yeah, it is. It's kind of a misnomer, because speed reading is not about it's the ability to capture a lot of information from reading, but it doesn't necessarily mean that you're like reading things faster. You're selecting what you're actually reading. So for example, when you're reading a book, what I do I read the book. I think speed reading is an absolute critical kind of a skill. Like, I think I can read a book 10 times faster than somebody else.
Did you
How?
speed read the book Speed Reading?
No, I didn't.
Okay.
But it suggests that you do. The book itself suggests that you do it. But what you do is you would look at the cover, look at the table of contents, maybe look at the back, maybe read the first line of every chapter. It's about how you process a book, because comprehension is not about the fact that you're like learning, like reading everything. It's about repetition. So for example, if you pick up a book, like you just read a little bit of it, and there's skills for how how exactly you do it. Like one good skill is just read the first sentence of each paragraph. Like don't read the whole paragraph. If you want to get through the book to know like what the whole book is about, or even just read the first paragraph of each chapter, then you know what the whole book is going to go through. And then if you actually find it compelling, then read the whole book and read it again, do it again and again, and then get so much more comprehension out of it. But if you didn't like the first time, you spent half an hour on it, and then just throw it out if you don't like it, if it's not relevant to you, if you don't spend like 50 days to get to the end where you think, oh, this was worthless. So this is speed reading, and I think it's a way under-taught skill. And what I do is like I just scan things, like I go through a whole bunch of stuff. I just kind of like look at parts of it to get a taste for what it is. So it's about comprehension, not necessarily speed, but then you end up absorbing much more material. Now Tony Buzan, I think he's one of those initial guys. He did this work about speed reading, mind maps, and actually memory. So there's mnemonic systems. There's a book. If you Google Buzan memory book, I don't have a link here. I do like Buzan because he was one, like if you Google him, he's like one of the first guys that ever talked about mind maps. He popularized speed reading and like memory, mnemonic stuff. So he was one of those early guys. So I think he's really good. And there's of course many others. But I think those three skills are quite important. So if you can just absorb more information, not by reading fast, but reading selectively. If you can mind map things, to organize things, take notes, work on your memory. And there's a lot of different mnemonic techniques. Like I won't get into it, but one thing that does stick out for me is he calls it the Roman room, where in your mind just create this scene of crazy things or objects that you like won't forget, and then you can attach a thing that you're trying to say. You're trying to remember 10 things. Attach those 10 things to each thing in your room that you create in your mind. So it takes like, you have to work your mind to do it. You have to practice. Okay, now I'm going to create my Roman, he calls it the Roman room. I'm going to create this really unique situation that there's like 10 items, or you can put like 100 items in there if you want to memorize 100 things. So you invest a lot of time into creating that room, but once you got to remember 100 items, you can do it like that, because you're attaching, like for example, if one of the things is pizza, and you put like say a room, like a room with some weird table, huge table in the middle of it, you can perhaps then remember pizza because it's a flat thing. Just make some crazy image like that pizza that stretched over the entire table and over the edges to the floor. Like create some crazy association that now if you have to remember pizza, you're not going to forget that. So there's many different techniques, and you have to just, I think, be aware that if you want to invest into your ability to memorize things, if you want to do that, then you can do that. Like you see some crazy people who can remember like 1,000 things or whatever. I mean, they've practiced that skill quite a bit, and you can develop it if you like. But then you ask yourself, well, do I need that right now, or maybe not? But it's definitely worth having the ability to accurately recall like maybe at least 3 things or 5 things or maybe 10, I don't know. But it depends on your needs. The point being that you can train your memory to become a super performer in memory if you want to. It's and memory is, I think, it's relatively important. So
It's a huge
anyway.
advantage. It's a ginormous advantage.
Yeah, definitely an advantage but the memory thing is like about your learning in general. In memory, like the number one thing about memory is repetition, because if you do something once, you can easily forget it. If you repeat and repeat, that's how you actually learn something, by repetition. That's a known thing.
Rote.
Yeah, and developing techniques for doing just not techniques but like habit. So if you understand that memories, like you just told me, I'll remember that. Well, no, I mean our memory is like we have short-term memory, we have long-term memory, but we can very easily forget things. Like if you haven't written it down, it's like it's an exponential decay. Period. Like you're not gonna, unless you repeat it over and over, it's gonna be that exponential. And
When
like
you write
down
it down,
here,
you're likely to remember it.
you're not even gonna remember. Like I didn't do that, right? And it's well, may not be true. So memory is quite limited, and writing down, like I always carry my notebook, which is not here with me, but I write things down because if I want to learn faster, I know that when I get some experience, go to a lecture, do some, I'm gonna forget that like next day or 2 days. Like one day I'm gonna forget like 80%, 2 days like 90. By a week it's like 99.9%. It's like you didn't even go to that lecture, you know. So it's like, is that what you wanted to do? Like just get entertained for the time? Well, if the answer is no, then you need to carry a notebook. And here we say we'd like everybody to carry a notebook to record things, because it's just assume that you're going to forget, and you will. And it helps everybody, because if you have that, then you don't have to ask that person that gave you that information or whatever. You just become more efficient and effective in whatever you're doing, because you're not spending time, you know, looking for lost information. You can, and especially like if you get your notebook, then if you can index it in any way that's useful to you, find ways to index. Like for example, I have my notebook and I actually put an index in the back. It's like I talked to, you know, whoever. I talked to Barry about Treehouse. If I want to remember that you know, because there were some very important things we talked about, including like how this work was similar to the founding fathers. I wrote down your quote. I know I can retrieve that just by saying, okay, Barry conversation and back index, things like that. These are practical things you have to kind of discipline yourself to do. But I do some of that. So team learning is a way to learn more rapidly. Like if you're in a swarm environment, like when we're building in a shop, you'll look at other things doing things, and you can learn from that. Definitely could rub off to you. That's where like having more people doing, like for example, if there's 2 people cutting those tapers for the roof, if you're cutting by yourself and you got one guy next to you, like you're just gonna do whatever you did. But if you had like 2 or 3 or 4 or 5 people doing that, then you'll be like, you see that the guy next door is doing like twice as fast as you, or like twice as slow as you. So then you'll go up to him and say, hey, I'm doing this and I'm doing it twice as fast. Or if he's doing it twice as fast, like, hey, what are you doing there? So you'll naturally get people at different forms of performance. So that's why swarm builds are so important. And that could apply to digital or real work, where the facts are that there's this 80-20% rule, like 80% of the productivity or product comes from 20% of the work. Like, man, I forget what that is called, but so
Pareto's principle.
is that what it is? So for example, if you have 5 people in a workshop, you have to understand that. Well, it's kind of hard to see how 80% are doing, like 20% of the people are doing 80% in a thing that's like identical, but in general that tends to be true, and that the performance level between people varies quite a bit. So if you have groups, then you can actually pick out like who's doing the best stuff. In collaborative learning, you can actually say, hey, we're in an open learning environment here, let's share how you do that because you're doing it better. So team learning, like for example, when we build the houses, you can have some rub off from people doing things in a more effective way, so that's effective. Modular breakdown, I talked about that a little bit. Let's see. let's go back to let's go to some other concepts about effective learning. So we talked about team learning. Mental models is that's a whole other ball of wax here. So mental models are things of like kind of with general semantics about forming accurate mental models. It's like shortcuts that allow you to understand something, and you form them about different things, whether it's accurate mental models or prejudices or whatever. But there's a large number of mental models. The thing is if you can apply mental models, that means shortcuts of how things, like how reality works. You've got those core principles in your mind. The more you learn about them, about all kinds of things, and I won't get too many details here. If you can learn how to apply them, then you're faced with a situation, you've got bam, solution, because you recognize the pattern that came from your study of mental models to solve that pretty much immediately. There's a really good side I like about that. Farnham Street, actually there's this one blog. It's actually a really cool thing, and you can link to it. You know, like probability errors to avoid, whatever. He's got a podcast where he talks primarily about mental models. He's huge on that, and he's got a book about it too. So if you want to study more about it, it's definitely worth contributing to either, like, you know, we started this mental models page on the wiki, but you know, a mental model like 9 forms of capital. Oh, cool. 8 forms of capital. What is this mental model? Well, people have already defined it, that capital cannot be just money, but all kinds of other forms, like ideas, like resources. 8 forms of capital. You can go through this, but it's a mental model that says, that now if you know that mental model, you're like, oh, how am I going to start up my OSC campus? I don't have any money. Oh, well, if you understand that there's 8 various forms of capital that can get you to the equivalent of what money does, then you've got a solution. You know, so it's important to have a mental model for any situation, and you can study that actively, and it's a whole study unto itself. Mental models. How about looking at things from different perspectives? So actually, there's this thing. Probably anyone heard of this Zachman framework? But it's how you look at an enterprise, a productive enterprise, from many angles. So I talked about a perspective from varied points of view, and this kind of defines. It's like, how does the actual technician, the builder, or the user look at that thing? So for the house, we're looking at it, okay, I put that window there. Is that going to be like provide light for that person, or is it in the right place? So you look at it. So say you're designing a product. If you have the Zachman ontology or framework in mind, you're going to automatically start thinking in multiple dimensions. Okay, I need to consider the user. Okay, technician. I'm going to say, oh, well, Katerina, you designed this, but okay, I'm going to build that. That's not easy to build. So as the technician, I'm going to say, no, modify this. So I've looked at it from a different angle. Whereas, say she was the engineer, Katerina was engineering this, she looked at it from the engineering perspective. It was sound. Well, I said, no, I'm going to build that. So the more perspectives you have, you can carry at the same time, the better design you're going to make. Like the architect, he is developing the concept of it, whereas then the engineer defines the technical aspects. The actual technician builds those. The user uses those. The executive runs that, the big ideas behind that. And then so that's the different kind of people that look at a process, and you can break down the different abstractions of how you look at things, like along the questions of the different questions of what, how, where, who, when, why. So what's an example? Like if you've got, what is it that you're designing? How are you let's talk about the design perspective. What are you designing? How are you designing it? Where are you designing it? Like, for example, if we decided to build the floor inside the workshop, that was a very deliberate decision as opposed to outside, because we control the tool environment and the weather inside the workshop. So that's when you look at it from where, you say, oh yeah, that's definitely got to happen in the workshop. Who's going to do it? questions, you ask that question, when are we going to do it? We're going to save the world right now, so we need to act immediately. Why? Why are we doing that? Because of our moral intelligence that drives us to particular ends and stuff like that. So there's all these different perspectives. Then there's other ones. Including motivations, timing, responsibility, like who's doing what, how are you distributing things, how are you designing the process. I just think that this kind of framework, once you start, the main thing I get out of this is those 5 different roles: the architect, the engineer, the executive. Think about that at all times when you're in a large collaborative team and when you're learning. And for optimizing your learning, you'd have to start thinking about all these aspects when you're trying to develop a successful enterprise. So I just want to bring that up as it's a very useful framework. So how do you accelerate now? And accelerate. So we talked about speed reading, memory tricks, just superficial discussion of that. I think construction sets are a huge idea in terms of how you can accelerate the development or your learning, because then if you have building blocks that you can understand, so modular building blocks that have certain functions, and you can combine them. If you have X number of blocks, like you can combine them in like whatever, X squared or X to the nth power in many combinations. So if you can study the building blocks and design construction sets out of them, then, for example, we can do a construction set for tractors, which includes, now we can do trenchers, bulldozers, trucks, dump trailers, and any kind of mechanical device related to something that looks like a tractor. And therefore, you didn't spend all your time learning how to do a tractor, you learned how to do the entire product ecology around that. And that kind of model of construction sets can apply to anything. There's a well-known book by Christopher Alexander called Pattern Language, which talks about all the kinds of different designs, elements that go into house building, all kinds of very common structures and features. So if you understand those, you can say, there's a pattern there. I can apply that. I can use that directly or combine it in different ways. But you got to know that it exists as a building block. So if you can study the building blocks, I think that's one of the most important ways that you can diversify your ability to create in many, many ways. And then you have to, of course, handle all that information. How do you handle it? I say you handle it through tools like Mindmaps or other ways that you can index large amounts of information. Just like in the development process that we use, you saw the modular breakdown where you got each machine, you got its subparts, and you've got so same machine, like 50 machines. Each has, say, like 12 modules, like a tractor has a frame, an engine, controls, etc., hydraulics. So you got 50 by 12, that's already 500 things. Then you got about 40 development steps for the machine itself. You go through, here's the conceptual design, starting with requirements at the highest level. You go to concept, you go to start fleshing out the technical implementation and so forth, and then the actual design and build stuff. But when you start multiplying that, it becomes an intractable number, and therefore it gets into mind maps or taxonomies of what are you calling all these things? So you have to have a uniform way to name things in order for this kind of construction set approach. Or, I mean, we're literally saying, how do you redesign a whole civilization? There's a lot of elements there. You have to be able to handle and process a lot of information. But the important thing is you need to understand, like you really emphasize that architect view, where, for example, in the product development process, you know that that's got these typical 40 or however many, you can get into as much detail as you want, but 5 steps like concept, design, CAD, build, data collection. You're going to break it into 5. But you got to understand those big buckets and then more granular breakdowns. And that's more like the architect role, where if you can embody that viewpoint, then you can handle a lot of information. And I'm talking really like from the executive perspective, as in, if I'm the executive, I care about all those layers. I'm not just going to operate at the executive level. Like some people might. Like I want to make sure I get on a factory floor and be the builder, be the user. Like if you can integrate, like I use my tractor, and that's how, or the house. Like we're living in a house, so therefore we have to be responsible for how we do it. So if you can integrate all those layers into your design, you're much more likely to succeed in something that works and is benign as opposed to evil. Like if you're trying to create something like whatever, say the OpenAI guys that started with OpenAI, they were hoping to save humanity with open artificial intelligence. Then they made it proprietary and try to make a lot of money with it, and I think they got pushed back into open. But it's like if they can, I guess what am I trying to say there? If you embody multiple perspectives at the same time, meaning this integrated multi-perspective approach, which is what I'm talking about here, then you can be more sure that you're creating responsible futures for the world. So in other words, like when I talk about learning and the very basic need for learning and learning effectively, it's because responsibility is a big deal. It's ultimately when you're ultimately responsible, you're like a god because you're taking care of just about everything. You have to be a real steward, and to be a real steward, you have to have just a very diverse skill set to be able to perform that role, all kinds of capacity. So, like for example, we also do for pattern language. We've developed this thing like, this is from years ago, but here's basic elements, and then you can start. This is kind of like almost like mind mapping. So you can combine pattern languages with mind mapping. And for example, this is how I represented a brick press. It was a structure, a heavy frame with 2 hydraulic cylinders, and those are symbols for linear actuators. So you can start mapping things out into their basic element. Like for example, a car looks like this. I thought, okay, it's got, well, no, what is this? That's no, that's not a car. That's something else. This is transportation cars. So you've got wheel units, drive units. Like here, I was actually looking at boundary layer turbines, which are actually really inefficient. So this is like outdated. But different simple symbols which you can use to represent complex entities. So this is like a combination of graphic language, mind mapping, and indexing. Because say you did this as a representation of your vehicle. Like here's the frame. You click on the frame. Say you're using computers, and you're on the internet. If you click on a frame, you get taken to all the development about the frame. But it's a useful thing that you're saying, okay, I've got some wheels, I got some fuel, I've got some, I forget what that meant, but we got to basically work on developing. I think there's like 500 of these basic symbols that would make up literally like all technology. So imagine you can now even design a spaceship and microchip production using those 500 primitives. And what are those? It's going to be like a rotating shaft. What is a device that makes like micron precise surfaces, like it mills it? It's basically a super smooth shaft that rotates. It's called an air-bearing lathe, for example, but it's actually a super smooth shaft inside a cylinder where there's no bearings. There's actually air. It's just the separation between it. But that's like, I would call that's one of those mechanisms. That's an air bearing. What about a standard bearing that we're used to? Oh yeah, that is super critical. Your car would not drive without it. Probably even the disk drive inside there might not even work because it spins. Your not toaster, but say a lot of devices like your fridge, the compressor would not work because it's a rotating shaft with bearings. So it's like there's all these primitive elements that are now common to thousands and millions of products. So if you can define the ultimate subset of them, you can do really well to understanding all of technology. So you have to, what I said before, if you understand the construction set approach, you can start deriving crazy stuff by a fundamental like first principles approach to what goes on. So I actually started this 500, I call it 500 modules. So we talk about 50 machines, but all those 50 machines are going to have these 500 modules. It's modules. So kind of you can kind of take a look at, you know, this is kind of like a working list, but like materials. This is kind of like a rough brain dump of all kinds of things that trying to break down technology into its primitive elements. And this is not complete or anything. It's a big list. But you know, things like that are absolute, like shafts, bearings, motors. You know, maybe you do a spring, like, and then you see that, like for example, a ratchet is made of a spring and a gear. You know, like there's fundamental mechanisms, and then there's also on the other level, there's in software there's algorithms. But say you map out all those mechanisms now, if you understand them at a fundamental level, you can design and build anything. Now you'd have to do calculations and other things around that, but that means you're learning physics and calculations like as a very core, like a fundamental skill set that you can then apply to just about anything. And for algorithms, like how do you do like a computer vision tractor? Well, people already have developed an algorithm how you recognize an object and things like that. That goes into the category of algorithms. There's going to be algorithms for, okay, how do you do mathematics, or how do you, well, for us it's like self-driving cars and other things like, but algorithms then fuel like they're like the primitive building blocks of all the software world. And there's going to be like a fundamental set of those too, if you can actually notice that, like if you can see that. I can assure you there's a finite, limited number of technological hardware items. It's not like there's going to be millions or trillions and it's like unlimited. There's like only so many things that are like worthwhile studying or whatever that compose everything. And the same applies to algorithms. I don't have a great feeling for it because I didn't do a lot of programming, but it also applies that way. I am sure it does. And if you can understand those algorithms, and then you can understand how to combine them together, then you can program up anything in a second. And now you have tools like AI that you can, so AI collaboration, I'm going to get to that. I think AI is, I didn't really mention it, but AI as
the
an
programming analogy is like, it's almost like you're talking about like libraries, where all
Yeah.
libraries and API plugins, right? Where
Yeah,
you
yeah,
use
various-
this and you just like lock it in and you have access to that whole thing.
things like that. But underneath the library, see, because the library might be different for different operating systems or different languages. So you have to look at, well, what is that library, like what is the actual logic underneath it, like more than its implementation in the particular language that it's written in. So things like that. But yeah, that same concept. Now AI, like it's actually a complete game changer. Like for example, I designed the trusses using AI, so I basically fed it all the information. And what AI does is, I mean, you have to have some knowledge that you basically mid-course correct the AI, because it's not so advanced at this point. It may be tomorrow, but at this point, like, it makes a lot of mistakes. But it's definitely a helper because you can interact with it, and if you think it's not doing something correctly, you correct it and it corrects itself. But think about the idea of the truss. I mean, so I said, okay, I've got this design, and I just wanted to know how much load it can bear, and so I asked it all these questions. Just do the calculations, like well-known calculations. Like I asked it, okay, give me like the weight it can withhold, withstand the actual tension that will be formed. Like AI could do that. Those are just, once again, kind of like those algorithms, like mathematical formulas that say, like for example, force equals mass times acceleration. Okay, well, I know how hard that car is going to hit the wall when it hits a wall. You've got known laws, and the AI is good at applying very well-known stuff, and then you can actually parse it to say, hey, calculate how much this piece of wood will hold when I stretch it before it breaks. Like, you can do exactly that. You give me a 2x4, calculate how much or let's say compress, because I want to hold the roof up with it or whatever. How much will it compress before it actually breaks? And it uses things like, oh, this is the compressive strength of wood, which is a known engineering quantity. oh, it's like this is fir wood and it's got these properties because humanity knows that fir's got this compressive strength. And you can do all kinds of cool stuff with it. So it's pretty useful. So I was able to basically say, here's the chords and here's the OSB, and it understands those things because it knows it can correlate properties that are known data points to that. And I said, okay, design me this truss, and I want it to hold 50 pounds per square foot. So it drew me a graph of the tension, and I said, oh, does this work? And I tested it by saying, oh, okay, at this point it gave me a graph of here's the tension on the bottom chord, and if that's within the acceptable tension of wood, for that kind of wood, which is a 2x4 made of SPF, spruce, pine, fir, then I said it was okay. And it did that. Whatever, say the tension there was 2,000 and the wood can withhold up to like 2,400 pounds of force for that 2x4. And I said, okay, cool. I was able to design it that way using actual graphs. Like, I mean, just to give you an example what it did, I think it's worth understanding like the capacity, and this capacity is going to be improving over time, but I think it's under truss calculations. I just want to show you like an example. No, truss design. Let's say truss design, just as an example of yeah, like what it did was actually generate these graphs. So look at this. So this was how much tension would be on that the bottom chord. So this, I asked it to give me the tension on that. It graphed it out because it understands the geometry, and then without any reinforcement. So I said, okay, but give me like a 16-foot reinforcement in the middle. So if you reinforce it like this, it's going to reduce that tension in the middle from 4,000 to 2,000, making it acceptable for spruce, pine, fir. So I said, okay, there's my truss design with that 16-foot reinforcement. And if it was without it, it didn't make it. So, I mean, this kind of stuff you can do in artificial intelligence these days. Useful tool. So let's talk about also, just one of the last things, concurrent engineering of how you can radically accelerate development time, or like this is organizational learning, like group learning, group development of a process or product in which many people can collaborate, and therefore you've got various kinds of roles. Typically, there's the waterfall approach where it's a linear process, completely linear, like the engineer is going to come up with requirements. They're going to go to design, implementation, verification, maintenance, or whatever. Well, concurrent is where you're doing all of that all at the same time, because you've defined the problem in a way that allows you to do that. Like it's just a choice of an approach. Like you can do it, oh, okay, I'm going to just do this now, and then once I have the concept, I'm going to do the actual CAD. Well, there's nothing that says you can't start doing the CAD without even the concept if you have some beginning information to go on. So if you have limited information, and at the beginning you're starting, you have limited information, but the point is that you can actually start all the different steps at the same time. That's the idea behind concurrent engineering, is that people have some information to begin with, therefore they can start already. So, and what we do in OSC development, you can come up with this crazy thing of doing all kinds of steps at the same time. How do I make this test-driven? It's on a test-driven design page. But this means that, like in the development process that we do, if we had enough people, we can do all kinds of steps all at the same time. Like right now, okay, so what are some of the things? There's prototyping, there's validation steps, there's bill of materials generation, there's testing, there's CAD design, there's CAM, which is computer-aided manufacturing. All kinds of different steps that can happen at the same time. And this is more about group learning than just individual learning, because each person participates. But once the whole thing is developed by multiple people, you can absorb, they can teach each other, and you're teaching each other. But the way we do it here is we're trying to develop a method where all the different steps, if you have enough bodies and enough skill, you can tackle all those steps all at the same time. Like for example, right now, if we had the 3D printer guy and a CAD guy and all those other people right now, we could be designing the 3D printed fittings that we can print that entire tube on a 3D, the whole waste processing PVC on a 3D printer. And like, it doesn't have to be in the waterfall approach. It's like, well, maybe, well, in our approach, the point is you can do it all at the same time depending on how many people you have. So so rapid learning, I think that's pretty much, I don't have much more to say. It's to summarize, also we got to say that all learning today is highly disintegrated, and I was really frustrated by that in my grad school and college experience, where the farther I went, the more useless I was feeling in terms of solving pressing world issues. But in an integrated approach, where especially if we take the different viewpoints of all the different parties that are related to, we can say product development or whatever we're learning or developing, take multiple perspectives, multiple approaches, take all the different disciplines, work on your ability to read, absorb information fast, organize it. And each of these things are just a huge thing in itself. But the biggest thing we talk about is get your mind around the idea that all of this can happen with multiple people at the same. There's really no limit as long as you can understand the architecture behind this whole process. And if you have tools like construction sets with fundamental building blocks like Legos, it's an extremely powerful approach. But the thing that you have to have is that awareness that all these things are possible and exist. So you have to increase your literacies, and there's the literacy part in intelligence is to first know that there are all these things that go into a design or a learning process. And once you start becoming aware of that, you can start learning that. But that's if we're going to talk about, I guess I'll wrap up with a statement that if we're going to try to transform systems on a planet and transform different institutions from agriculture to housing to everything, because that's what we're saying. We're saying, how do we solve housing, right? How do we solve energy? How do we solve the healthcare thing? Oh, I'll look forward to that because we can get some creative approaches on that. Just look at what we're doing with housing right now. I actually kind of get excited about it because it's like, holy cow, because that problem of healthcare in this country, for example, that is huge. I don't know is it even bigger than housing? I don't know. Maybe.
Say as big.
As big. So
and aging population probably bigger.
Yeah. So if we ask the big questions, we have to have an expanded mindset to handle actually arriving at solutions. And I must say that any kind of transformative experiment must have a process for rapid learning built into it. Like, you cannot right now, like a lot of people say, oh yeah, we'll just get this group together. And I think the first thing you got to do is you got to build it around education to bring everybody up to a higher performance level. I think, Suzanne, you got that going on. Yeah. You're starting with education. We're starting with education because that is, we will fail miserably. This will turn into Lord of the Flies very rapidly. And it has. Back in 2011 when a whole bunch of people came here, it was just chaos and stuff like that. Without uplifting people to responsibility, skill sets, productivity, that's ultimately the driver behind the prosperity that we all want, right? So you got to start with education and improving your skill set of metacognition, meta-learning, learning how to learn, which is, we'll be delving more into that throughout the program. So any questions that come up, we'll wrap it up at that and maybe take questions from the audience.
Marcin, you've got some stuff on the right side of the page here on the TFC page. Can you talk about that a little bit?
More the rights. Oh yeah. So the open learning environments. So actually, you got to in terms of learning, you got to start with the landscape. The landscape should educate you. Start that process. So for example, what do I mean by that? If we have flowers, if we have like pears and peaches and food plants around, or integrated design that's aesthetic or food productive, you say, wow, that's pretty cool. I can grow food like right next to me. Instead of say you're like in an urban environment where it's only concrete, that's going to teach you that like you're going to be ignorant. Like, where does my food come from? you don't know that, and the environment should teach you, starting with that. Like, for example, in a visual workshop, what is a visual workshop? Instead of having like a blank workshop, Google visual workshop to get an example of the open learning environment. So if you look at visual workshop, the workshop itself is educating you. That doesn't have to be visual workshop. No, visual factory, factory.
It says right there, visual thinking workshop.
Like this, kind of like this, where there's things that, I mean, this is an example, arrows that tell you where to go, you know, things that, like, for example, outlines of tools on a wall that tell you where to hang each tool.
You're talking about the Toyota method.
Yeah, exactly. So that's where the environment is actually teaching you. If we have, for example, a microfactory, some housing, some great agriculture around here, that teaches you that, wow, an integrated, healthy environment is teaching me that, oh, you can produce things, even how to produce things, because you see that factory, that microfactory being transparent and open design. Maybe like it's kind of like guided tours in nature. It's like, let the environment start teaching you. Just like architecture, like if you're in a ghetto, all you're taught is that, oh, things are messy, there's garbage, and that's what humanity is about. You have to start building that beauty, functionality, inspiration into the very environment. You got to start there. And it doesn't have to be like we're formally learning here. The environment should start with that. So for example, the rapid learning facility, how do we apply that? We're setting up the base, and we will have dedicated kits where, say you have, you know, like the PEX, the cross-linked polyethylene and shark bite fittings. Here's like all the parts, and then maybe you have a visual diagram. Oh, connect these two together and see how they go together, and to make these complex assemblies right there. Like, for example, I think a good example is the water service entrance, where it takes a plumber to build that in, like, takes a couple of days to build it. What we can do is it'll take you like an hour to build it. Proven. I've done this.
For what?
The service entrance, which includes the fat water pipe, pressure reducer, valve, distribution piping, other elements like a connection to a pressure expansion tank for hydronic heating, and other elements which are all at the service entrance level. It's like a whole bunch of things, but now we're using shark bite fittings, which are plug and play modular units. We have a diagram. Like, this is such a cool thing, because like, if I have that diagram in that rapid learning facility, you can see, okay, here's we'll see this later, but for example, this thing is so a visual representation of that, all the parts, maybe like even with outlines that are not connected, that you just get to connect because that environment has shown you and informed you, directed you to do all of that already. Then you can learn rapidly, because you don't have to spend, like, it'll take you like 10 minutes just to gather up all the parts. Here, like in 1 minute, you actually put the whole thing together. So it's just a rapid learning environment which gets it all ready for you. And just like,
You still need the 10 minutes to gather the parts, though, right?
well, not if they're already laid out on a, like, say that it's laid out on a wall, like some kind of a thing, or on a table, which is, this is your learning
That's the
table for
visual
hydronics.
factors type thing.
Yeah, and you have that there, and it took you 5 minutes for that lesson, and now you practice that 10 times, and now you know how to build the entire service entrance, which a professional plumber would take you 2 days or 3 days and probably charge you $1,000 for, and you did that for like in under an hour. And this is real, like this. You know, this is the kind of optimization that we do. It's kind of obvious, but it's because shark bites exist, and you can design it to be rapid. Because I know that these things are super complex if you don't design them from the ground up to be easy, manageable, plug and play.
Should.
Right?
Think that's
Which-
part of,
yeah.
I think that's part of the for-profit model system, and the requiring of licenses and all that is to separate people from the simplicity of it, so that they have to pay somebody else to do it for them. And like, I think it's designed
yeah.
into the system. It's part of
access,
it's
privilege.
Yeah, I mean, it exists, and whether it's plain evil
intentional
or
not. Yeah.
not, I like to say a lot that we're just super retarded as a species too. I mean,
For sure.
and
You're evil or incompetence. It's one of the
evil incompetence. I think it's most of it errs towards the incompetence side, because think about evil. I think evil is the practice of incompetence. It's like they're kind of related in it.
They are.
Because you don't have, like, for example, if you're
One's more solvable than the other.
right. Because evil is the mindset that you're not actually questioning that incompetence, right? You say that, oh, this is cool. This is the way it's going to be now, and I run the show. So that's
That's intentional, right?
Yeah, I mean, it's just a failure of a growth mindset, because that person has
But
not
there's
cultivated
also
that.
just people out there.
Yeah.
I mean, it's not all ignorance. Not everyone's deceived.
Now, what a good social experiment would be like if you provided. I mean, that's kind of how we operate. Is we say, like, the guys that the big companies that are so-called our opposition. They're going to take up our stuff and do it when we show them how efficient, productive it is. Because what we're driving for at the end, they are not opposed to abundance. They don't understand that it's possible for everybody. But if you show them a good way to do it, and we might question that or not, but I think a lot of people.
Okay, I agree.
A lot of people would be transformed by it. There might be like the super hardcore evil people that they're really set in their evil ways. But in general, I think there's much more room for transformation because of that. When we talked about neuroplasticity, even maybe that person tomorrow grows a new brain cell and they actually convert it to an abundance mindset. Maybe that did push the trigger.
Or they got pushed through a rock and a hard place.
Yeah, got put through an extreme experience or whatever that changed their mind.
Can I ask a question?
Yeah.
So about speed reading specifically.
Yeah.
Like you were saying that you will read either the first line of a paragraph or the first paragraph of a chapter. So don't you think that you miss a lot of stuff that way by basically making a preconceived judgment with limited information?
It depends
right?
where
so you miss something. I mean, I'm not always, but a lot of times I would argue that you're not really reading that entire book. You're reading the little parts that help you make a quick judgment to move on. So you didn't take the actual time to ingest what the person was trying to describe. So that seems like a very easy mistake and a big problem to fall into. And like I'm not saying it doesn't allow you to cover lots of material, but maybe you missed a huge portion of the latter material that you immediately dismissed as insignificant because of you only read the first paragraph of every chapter, and maybe the first paragraph sucks. Like, I want to write a book that says called "Wrap It Up, I'll Fake It," right? About my fighting career and the outfits we wear in society, right? But the first chapter is going to be the history of Vaseline. Right?
There you go.
It's a lubricant.
That's pretty divergent.
It's anyway, most people, if they read just that first paragraph or first chapter only, I would say would maybe just set it down, and then they miss the whole point of the book, which is they
there's two
right. So
to
that's
answer
a
that
fine line, right?
No, I get it, but I think there's two points that, because I would make sure that I get enough scope of that book. Like, I'll read this. It's like, because you got to spend enough time to become convinced whether this is worth your time or not. And most times that really works because the other side is the author a good writer? Because the proper way to write things is that, well, the first chapter of a book should be
intriguing.
The big picture of the book. The first paragraph of each chapter should be the main idea of that chapter. The first sentence of each sentence of each chapter, according to writing well. So now you study how do you write well, and when you study about how do you write well, you will learn that some of these principles, like I mentioned, are there. That the book should. I would hold on. Like convince me if I'm wrong. But if I were writing think about this. If I'm writing a book, like, here's the introduction chapter. Shouldn't that introduction tell you what the book is about? Right?
Sure.
Yeah, it should.
Well, or
Or-
provide an intrigue, right? That makes you
Yeah.
like, why are they talking about this? I
So
thought
so
it
I'm
was about
saying
this.
so I'm saying
So
to
you
you.
could connect the whole thing, right? But you can't do that with if you don't have all the information.
Well, I might read the whole first chapter to get that feeling, and if I'm convinced, like, well, if the first chapter is not compelling, I mean, that I think is like I dismiss the author. It's like
Yeah,
cool,
fair enough.
right?
But
And then
you may be missing.
there may be,
Well,
but I mean, try this, and you'll find that you will at least I did, found out I've saved myself tons of time because before you even pick up a book.
Slow reader.
Well, I mean, try the method of like just start with the title and the back page. You know, some of the index.
Sure, I read the back.
You know, like
before I send it.
scan a few paragraphs. Like it might be that the way something is written is just like so oppressive to you that you're like, oh, this is BS. I just don't want it. And even before you even pick up that book, where'd you get the recommendation for the book? Why'd you pick up that book?
Well, and
Did you actually look into that process?
That's my point. Is I think that I guess that's why to me it seems because if I pick up a book at all, I probably it was recommended by somebody like you or somebody that I think is really smart, or there's a reason that I picked up that book.
Yeah.
Right. Something that I'm trying to learn. So for me, it seems like it would be worthwhile to invest more time in it just before you can dismiss it.
Yeah, but
accurately.
But I mean, then you have to recognize that you're individual, and if that book, like if it was really good for me, and I actually think it's really cool, like for another reason, it might not be the right time or whatever for you to read that book because you're just not at that place, and you might feel free to completely dismiss it. Like right now, if I tell you, oh, I thought Never Split the Difference is the most amazing book on negotiation in the world, if you read the first chapter and you disagree, put it down. You know, because I'm saying that book is compelling. It's written pretty well, such that typically the rules for how to write well. So on the other side of how to read effectively is how to write. Like there's lots of work on how to write. On writing well is one book. There's a lot of different books on that. But I mean, I think the fundamental principle about he actually talks about this. He discusses this concept of book structure in the rapid reading book, the speed reading book. He discusses how if the book is well written, and typically good authors like to follow the best practices, and they will do exactly what I just told you. That.
But aren't you? You're specifically not necessarily following the best practices in construction because you're changing, right? So to me, that seems like a weird way.
Iterative.
Yeah,
I am
you know
following.
what I mean? Like, that's
I am following the best practices and building upon them. Like I take, okay, they say do this, and I say, okay, cool. Let me analyze that, and then we say, okay, let's do it this way.
That's the iteration.
But it still has to
Right,
meet code,
so
things like that.
You're specifically not following the best practices. You're saying these best practices are flawed. I looked about it. I went to the first principles level, and I decided that I can do it better this way. Right? Isn't that not what?
No,
you're doing?
because you have to look at context. My context is different than a builder's context, than the industry standard. So we typically break industry standards because my assumption, so now you talk about, once again, the bigger picture, kind of thinking about more the architecture of the system. My architecture is wealth distribution, absolute empowerment of people, meeting real needs, education, like things that educate you. Their motives may be different, and therefore the design that I come up with must by definition be different because my goals are, my design requirements are different. Now they still have to be safe and meet codes and all that, but if my design principles are
But
different,
they don't have to follow the best practices that are currently.
but that's not a best practice for me. Like, I mean, I say I build upon it if it's relevant to me, but I have to evaluate the greater context to see how relevant is it to me with what
So
we want to do.
That's why I have a fundamental issue with that idea of the reading like that with the filter, is because to me that's goes against gathering of knowledge. You're not accepting all of it and taking it all in before you make a judgment. And I guess, but I don't know, maybe
Not take all, but I mean that's kind of like precisely the point. You don't.
you don't want to waste your time doing it. Right? I mean,
And then you might say, am I biasing myself
That's what
for
I'm
selective
saying.
learning, and then you
totally are by what you're deciding is the relevant key points that you want to read, and so that whole speed reading thing to me is flawed. Like that. Anyway, I don't know. That's just my.
So I would start with read the book on speed reading and see if it makes any more sense after you read it.
Yeah.
Because right now you're talking without like having those assumptions, like the explanations that it has in there. And I didn't go much into it, but see if it makes sense to you. If you pick it up and you see it's like, okay, immediately this is like, oh, this is just ridiculous. Just put it down, and maybe there's some other method that.
I did do that, but 15 years ago, and I didn't write it down, so I forgot most of it.
But I can tell you the results. I can extract
you've been happy
content
with the results,
way faster than most people. So it's working for me.
It's good.
Yeah.
I'm gonna try.
And maybe like there's the other variation of the technique that I missed that part because it's unique to me, but maybe you come up with something else and you write next sequel. There you go.
I would say if I were me, like I really agree with both of you because I think the caveat is what you had said earlier, the time of season, right? Because you can go through a book one time and there's really things that will resonate really strongly with you, and then you put it down and you come back years later and you're like, what was it? And you go back and completely different parts will resonate with you and a different reading. And so I think that for me is one of the benefits of the speed reading is like I actually do feel like even our subconscious can guide us when we're scanning. Things will pop out at us. We have groupings of words that will pop out. And I think you can really hone in quickly on what
I think that's a good answer. Basically, when you start getting into it, you have enough evidence for you to make these classifications or judgments about it, because there's like thousands of books on that topic.
And
there's many different ways to look at it, and maybe that's just not the right one for you, and therefore you save yourself time of going through some pain.
And what do they say that like a lot of people can read if you type a whole paragraph and every word, only the first and last letter are in the right order, but you scramble the letters in the middle. Our brain actually perceives words as pictures, not or a lot of people's brains. That's why the Mandarin people use phonetic and image-based languages, high context-based languages. So it's interesting to see. Like I can do that when the letters in the middle are scrambled and the first and last one are right.
Yeah.
Like anyway.
Yeah.
It's just a crazy idea to me.
Yeah.
It seems
And just to wrap up, like in the presentation, I talk about deep generalists, but that's the aspiration that we have. Is we're not a specialist. Like a specialist would be. There's a.
Go ahead and finish, but stop on that picture because I have a question.
Okay. Yep. There's different forms of generalists. There's generalists, which are kind of like the jacks of all trade, but there's specialists, generalists, and deep generalists. We don't want to be specialists if we do not understand how anything connects to anything else. That's a formula for disaster, right?
Sure.
We don't want to be generalists who know just enough, but they don't know enough to do really good stuff. Like, that's cool, but you're not going to push the state of art in anything. But what a deep generalist is, they have deep knowledge in multiple, so they're the specialist in multiple areas. So they have pretty deep knowledge in not just one, but several different areas. And so they are, I believe that magical number is like at least 2 or 3, because once you see the deep connections in multiple disciplines, your ability to translate that to new disciplines just increases intensely.
That describes the general contractor that I worked for in Florida mostly, my mom's friend.
Yeah.
He had an AC business for a while. He was a licensed electrician for a while. He was a licensed plumber for a while. He ran his own sheet metal fabrication shop for a while. So he's like, he is the, what did you call it? A
deep generalist.
A deep generalist.
It's a deep generalist.
And it was always interesting to me to see why he would cut corners here and there, and then he would be like, well, because of X, Y, or Z, that's how it relates to something
exactly
else.
And that's the kind of
that made like anyway
that makes people
most sense to me.
Really good, and that's what you're gonna do plus 17 other trades in the 4 years, because that's the goal, and you're gonna be able to problem solve like that. Like you're gonna come up with solutions that that plumber themselves, the carpenter themselves, or some other specialists are never going to think of. And that's the beauty of the kind of stuff we're doing. No, I mean, yeah, I mean, you have to apply.
Earlier in the,
Yeah.
the patterns, right?
Yeah,
Being
patterns.
Like the patterns repeat themselves in all these
Yeah.
disciplines.
Yep, patterns. You get good at patterns. So once you see a few patterns, you're like, holy cow, this is completely relevant to these other patterns in this totally unrelated thing.
And then
And
I'm having
you become a genius. That's that. You get creative,
Pattern
divergent
recognition.
thinking. You don't think like every time it's the genius of and, like you don't see, oh, this is it. No, you see multiple
Sure.
options everywhere. It's called solutions. So there's no problems. There's just solutions,
Oh.
and it's a beautiful world.
The other thing that I'm
So-
having issues with is getting. I can't seem to Wiki won't ever let me set up an account to create an account to start the first thing. I've been trying for 3 days now.
Okay.
And I always get
Oh,
a blank page or I get a systems error page. If
Okay,
I'm in Chrome,
so-
it's a blank page. If I'm in Safari, I get a systems error page.
Yeah, I get an
And-
internal error.
Yeah, internal error, not systems error.
Can you
So
give me
it just
email me a
won't even-
screenshot? I need a screenshot. Can you just screenshot it and email it to me?
I'll see
Okay,
if
we
it
gotta
gives me
fix
the
that,
same
Send it
'cause-
one.
to James too.
Okay, because
James,
we
you're on
gotta.
there, right?
Yeah, because we gotta fix all that. We gotta get you all on a wiki and all that.
I've been trying for a while, but it
So-
won't let me.
Yeah. Okay, so Suzanne, what did you have a question on for this? Oh,
Okay.
that
Well, the
this
last
one.
that you had, I had a question specifically. Now I know that's supposed to be about priorities, but
View.
I mean, I really like the idea that you can do things consecutively, but there are some things have to be in an order, right? Some things are A, B, C, D, E, F, but other things can happen concurrently. I'm wondering about how this chart
Mhm.
helps to define the, because it had a label that it was going to show priorities, and I was wondering, is this like something where the priorities are closer to the center, and what's the advantage of this chart
It
versus
depends.
that Gantt chart?
Yeah, I mean, a different thing. Like this does not talk about timing. It's concurrent, so it's by definition not a Gantt chart, which shows timing of one thing to the next.
Right.
But it depends. It completely depends on the context. Like, what is this being applied to? Are we applying this to, for example, an induction furnace, which we never built before, or to the next tractor? Because in, say, the next tractor, we got a lot of different prototypes from before, and when you say you can only do A, B, C, like in sequence, well, no, we already did like A, B, and C for the other ones, so we can even go to
Jump
D
right
on
to
the
D.
next one. So it totally depends on the context, because you might have enough information from all those other things that you can break those rules. And I think the general tendency or goal is to say whenever you have, because what we're talking about, just to define what we're talking about extremely large, scalable numbers of people
Yeah.
getting together to solve problems that have never been solved before, right?
I see.
So if that is your presumption, then you must allow for the largest amount of creativity to happen. And whenever you have, oh, this depends A, B, C align, that means you've got a bottleneck on
So-
all the people that only can follow after A. So we ask, the first question we ask, okay, obviously there's some sequence that's required, but how do we break that requirement ASAP? So maybe we broke that requirement because immediately someone put in, some subject matter expert immediately contributed a solution for A. So the question that we ask is not how, this is kind of, once again, the abundance method, which we say, how do we ask first, how do we remove those blocks by maybe growing the team, getting a new piece of resource, getting another piece of capacity. Like, for example, if we're designing our induction furnace and somebody else in another open source project developed a whole computer aided design for the furnace coils and how exactly you do it,
All
we
right.
just solved it right there, bam, and then those people don't have to work hard. So we're always asking, the first question is, how do we the genius of and?
Yeah.
How do we get more resource, more
Oh, I
creativity?
follow that.
Yeah.
I got that.
So I have
So-
a follow-up or something on that. In martial arts, we have a thing, a lot of people say form dictates function, but it actually can work the other way too. Function can dictate form, and it's based on your perspective and where you're coming from. So like, you don't have to go with that base model and say that that's going to dictate how it's going to function. You can rather go and say, this is going to function this way, so I'm going to do whatever I need to do to make that work.
Well,
right?
I get that's going to look different when you're going through the
flip those two things.
Yeah, when you're going through the fabrication and the design process, that Gantt chart is going to look really different from after you have a prototype and then you're just doing repetition, cranking them out, maybe refining it. So okay, so that answers that one. I had another one a little bit back on at the very beginning when you were talking about the teaching method and the learning, rapid learning. You made a comment and you were saying that one of the best ways to learn is to teach, which I totally agree with. But one of the most effective methods that I have seen, it takes a 3-step approach where it says first you see it demonstrated, and then you
4-step.
You do it.
I do, you watch.
Yeah, and then
No, I do, you watch. I do, you help. You do, I help. You do, I watch.
Right, and then there's a modified version of that where there's just one demo and they all watch, and then you pair people up and they have to watch each other do it, right? They take a turn, but then they have to actually teach someone else, right? So if we're applying that model here, and I was thinking about for last night when you were talking about we're doing it Habitat for Humanity style. So somebody would come and participate in a bill, right? And they would see it being done and they would help out. But then on the next build, they'd be on 3 builds essentially at least, right? So then the next one, they would be working and mentoring each other. Like, hey, remember last time we did this? Well, and they'd be teaming up, watching each other's work. And then on the next, and maybe that's the one that they're building for themselves. But at some point, they're going to be turning around and actually doing the demo for the new people learning, right? So is that pretty much like you would expect somebody to participate in at least 3 builds?
I think the answer is that's my answer all the time. They're not necessarily exclusive. Like if we're teaching first, I'm just saying that make sure that part of that process is the fact that you're teaching too. You know what I mean? So does that answer the question?
Well, sure, but like for example, this time I can only teach what I've already learned, right? And I can turn around and teach it pretty quickly. It doesn't mean I have to wait until the next house that we build to teach, right? If I learn something, I can immediately turn around and work with a partner, and then the next day I can teach, right? So I'm just saying no signal.
Yeah.
Okay.
Well, we got to wrap up here.
Okay. I had 3 more questions, but that's
no. But I'm saying we're turning the lights off. But yeah, quickly maybe finish your other questions. No, because that's good. Because about the education part is super critical here. So go ahead.
Well, and also, so back to we've come up a couple of times with solving the world's housing crisis, and we talked a little bit about there really is evil out there. So I just always like to put a caveat in there. We can only help those who want to be helped, and so I guess in my experience, but also in the patterns with the world is we're not going to be able to help everybody because not everybody wants. Not everyone wants to be housed. Even with people that are homeless, like I have quite a few homeless friends that do not want to be housed. Right? So I'm just saying,
if there's a sense of freedom in not having to worry
about
so
I mean, there's but even those, and then we have people that are housed that have different priorities and standards. So I just want to be cognizant of that whenever we talk about it, that we can only help those who want to be helped, and there's unfortunately not going to be everyone wants an abundance mindset, because there's some that are the top looking down don't want anyone else to have abundance, right? Like because it's a competitive thing. But there's also those from the bottom looking up, like they don't want abundance because abundance equals work, right? So I mean, I always just make sure that that's like part of our realistic thing.
No,
of
course.
Knowing that there's always going to be dead weight out there.
Sure.
Dead weight.
20% of
that's why it's
80% of the work. Like
that's
in my rate, like rigging. That's very true. We got like people that ain't worth a fuck, and we only call them basically when we need numbers, right? And that's just the reality of it, because they're like they suck. They won't do for themselves. They they can do the job, but you have to say, hey man, go pull those points out there in the front of the house. Like, we're not done working yet. Like, put your phone down, get back out on the beam. Like, go do what you're being paid to do, right?
The reason it's significant in the context of what we're doing is there needs to be a way to filter for that, and there
Absolutely.
needs to be a way to like have an exit for those that it doesn't
Yeah.
resonate with.
Those are practical issues of how you design this, entry and exit.
And that's the only reason. I just always want to make sure that that is integrated in it, because the reason I say that is there's quite a few idealists that, right, like we like to pretend like those things don't work, but then they don't set up a system.
No, we have to set up the systems. I mean, society has shown us that obviously, like if, for example, if Russia is acting up, they gotta be knocked down, right? Things like that. There's evil that happens,
Yeah,
and
not just Russia, but yeah.
right. No, I mean,
Or we could give
you know,
some money.
we have to be realistic
Give them
about
American aid. It's what we do with Israel and Russia.
what's around. So, Suzanne, did you have any other question, or that was it?
I do, but it can wait.
Okay. So let's wrap up here. We'll leave it at that for our rapid learning discussion, and we'll see you again tomorrow. Thanks a lot.
Thank you.
All right. So there was food in there. Some of it might need to be heated up a little more. There's the soup, the tortilla soup. There's curry with rice, and then there is the meat and potatoes and green beans.
I put a big dent.